Good day, everyone. My name is Abu Michael, aka Ebu Miki. I'll be having a brief one on scalar multiplication, angle between line, and a bit of addition and subtraction with vectors. Alright, so not to make the topic very complex, I will just be going by example so that it will be fast. Let's say I have a to be 3i plus 4j, for example, and I have b to be minus 2i plus j. If I'm asked to find the scalar product of a and b, then the relationship will go like this. Actually, your scalar product will be taking the values of the x component, which is 3 and minus 2, multiplying them together. So I'll be having like 3 times minus 2, okay? Then I'll be adding it to the product of the vertical component, which is 4 and 1. Hope you know that the coefficient of unit vector j for a is 4, and the coefficient of unit vector j for b is 1. So that will be 4 times 1. All right, so this will be minus 6 plus 4, and minus 6 plus 4 is minus 2. Now if it happens that my vector has more than 3 unit components, maybe I, j, and k, it will be the same procedure. Okay, let's say for example that what I have for my vector is, let me quickly rub this one off. Let's say what I have for my vectors is a, for example, to be 4i minus 2j plus 5k, right? And b is a minus I plus 3j minus 6k, and say c, for example, or let me just leave it like that, a and b. Then the scalar product of a and b will be 4 times minus 1, okay, plus minus 2 times 3, all right, then plus 5 times minus 6. So this will be minus 4 plus minus 6, then plus minus 30. All right, so this will be minus 4 minus 6 minus 30. Obviously, the final answer to this question will be minus 46. So the scalar product of a and b in this example will be minus 46. This is how we do scalar multiplication. It is important you know also that your scalar multiplication can also be called the dot product. Now, because you have good knowledge of scalar multiplication now, you should be able to solve questions on angles between line, right? So let's say, for example, we are asked to find the angle between two vectors. What relationship do we use in addressing it? Okay, let's quickly check that out. I think this is simple, right? Okay, it's very, very simple. So let's quickly check it out. Shall we? I'm just thinking now, I wrote minus 46 in that last question, and I believe what I wrote down was minus 4, minus 6, minus 4, and minus 30. Okay, if that is the case, then our answer will not be minus 46, it will be minus 40. So sorry about that. It just occurred to me that I wrote minus 46 instead of minus 40. All right, so let's just proceed to do the other one, angles between line. If we want to do angles between line for two vectors, it will be cos theta is the scalar product of a and b divided by the magnitude of a times the magnitude of b. Is that simple? Or we can also extend it like this by cross multiplication, a b cos theta. So it depends on how you want your relationship to be written. All right, so we can use this relationship to find the angles between line. Okay, so let me just give a quick one using the first example. So guys, I'll use the first example and I will quickly do something about this one. Thank you. So let's say, for example, I have a to be 3i plus 4j, right? And I have b to be minus 2 plus j. When we found the scalar product of a and b, it was 3 times minus 2 plus 4 times 1, right? So this is minus 6 plus 4, Okay, that will be minus 2. So the scalar product of A and B is minus 2. Okay, now that we know the scalar product to be minus 2, we can find the magnitude of A, shall we? Magnitude of A will be, very quickly, magnitude of A will be, A magnitude will be square root of 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16, so that makes 25, right? Okay, and square root of 25 is 5. Okay, now for B, remember B is minus 2I plus j. I believe already that you guys have your notes probably by your side, so to make the class faster, so if I were to find the magnitude of B, that would be the square root of minus 2 all squared plus 1 squared, right? Now the square root of minus 2, the square of minus 2 is 4, and the square of 1 is 1, right? So 4 plus 1 is 5, and that would be square root of 5. So the magnitude of B will be the square root of 5. So if I were to find the angle between these two vectors, all I had to do is just to invoke that formula. I believe you took note when I wrote it out the first time. So my cos theta will be the scalar product of A and B divided by the magnitude of A times the magnitude of B. The magnitude of A happens to be scalar product of A and B is minus 2, right? Then magnitude of A is 5 and magnitude of B is root 5. Okay, so that will be cos theta. Now you and I know when we see stuff like this in mathematics, we are supposed to look for the arc of cos to get the angle theta. So we'll look for the arc of cos to get the angle theta. Can I quickly write that down? Okay, let's quickly do something. So I'll just say theta, right, is cos inverse arc cos of minus 2 over 5 root 5. Now if you press your calculator correctly, hopefully you'll be getting over 100 and something degrees. I'm not with a calculator right now and I cannot process this mentally, so I strongly believe that, because I've done this before, so I strongly believe that the answer will be 100 and something like that. Okay, so probably 100 and something degree, or maybe 103 degrees or something. Okay, so that will be to find the scalar multiplication. Well, there are times in physics or in mathematics where you may have to, do a simple addition or a simple subtraction. So let's say, for example, I'm taking the last part now. Let's say, for example, for this class, let's say, for example, we are supposed to do this. Let's say if A is minus 3I minus 4j, for example, and B is minus 2I plus 3j, and I'm supposed to find 4a minus 2b, okay, something like this, or find p, which is 4a minus 2b. Then our second question may go like, find the magnitude of p. So we have a 2-in-1 question and we want to quickly address it. Please don't forget our a is minus 3i minus 4j and our b is minus 2i plus 3j. All right, so quickly let us, I believe you are writing it. I'm writing it in my pad so that I can quickly type it out and give an answer. Okay, that's what I was doing. All right, so quickly guys, let us do the 4a. Okay, shall we? So I'm rubbing all of this up. Now 4a will be 4 bracket minus 3i minus 4j. Okay, that will be minus 12i minus 16j. All right, then our 2b will be 2 brackets minus 2i plus 3j. So if we do this correctly, this will be minus 4i plus 6j. Okay, that's the minus. So we have 4a to be minus 12i minus 16j, and we have 2b to be minus 4i plus 6j. Okay, so we bring them together. We bring them together and we just finish this thing very quickly. So we'll bring them together very quickly and just finish up. Okay, so guys, watch how we do this thing now. Okay, so to finish up, I will just say 4a, which is minus 12i minus 16j. Then I'm supposed to say minus 4i minus 4i plus 6j. I believe you should know that all of these should be in brackets. Anytime you have an entity before a minus sign, everything should be, in brackets. Okay, so guys, this will be minus 12i minus 16j excuse me, plus 4i minus 6j. So we just do that thing we do with our normal algebra. I believe you guys know what I'm talking about, a collection of like terms. All right, so this will be minus 12i plus 4i. That should give us minus 8i. Then minus 16 minus 6 will be minus 22j. That's about it, guys. That is how to get that vector. So we have minus 8i minus 22j. Okay, 22j. So very quickly, we can find the magnitude of this expression. Now, to find the magnitude of this expression will not be hard, will it? So if I were to find the magnitude of p, right, I'll just do that. Minus 8 all squared plus minus 22 all squared. Okay, then you just impute your values and you get your answer. Like I said originally, my intention is not to take your time. My intention is to make sure that this concept of vectors is actually a very simple one. All right, so you press in the value and tell me the answer in the next slide. Thank you very much, guys. I see you in my next class. Thank you very much. Take care. Bye bye.